Okay, so this starts with exponents. Exponents, exponents, exponents. So again, we've looked at exponents before, but let's remind ourselves. This would be referred to as an exponential expression, where if we define the individual components, a is referred to as the base, and n is referred to as the exponents. Interchangeably, we use the term power as well. So we can call n an exponent, or in the book, or you might also hear it referred to as the power. Okay? The whole thing overall, a to the n, is called an exponential expression. So a is the base, n is the exponent. What this means in terms of mathematics, what we want to do is we're going to take a, and we're going to multiply it by itself however many times n is. So something like this. If I have a raised to the n power, I'm going to say a times a times a times a however many times n tells me. Okay? That's our rule. That's all an exponent is. So if I start with a really easy example, if I'm asked to take a look at, say, 3 to the second power, all that means to me is I take 3 and I multiply 3 by itself however many times the exponent is. And it's 2, so I'm going to multiply 3 times itself, and 3 times 3 is 9. Okay. Now, one thing that comes up a lot and is a mistake often made, so let's get it out of the way right now, is the difference between this and this. Okay? So let's talk about this. If you have a number and a negative number, in this case, in parentheses, and that whole parentheses is being raised to that second power, then everything inside of that parentheses is going to get written out, however many times the exponent says. Okay? So this I would vocalize as, this is negative 3 to the second power. So I'm going to take negative 3 times negative 3, because it's only 2 times. Okay? And that, negative 3 times negative 3, is also positive 9. So this one's going to give you an answer of positive 9. All right? This, guys, we don't vocalize as negative 3 to the second power, because I just told you negative 3 to the second power is this, something in parentheses that we're squaring. Okay? This, we would say, is the opposite of 3 to the second power. So you actually do the 3 to the second power first, and then you apply the opposite sign. Okay? So in terms of what comes first in this, it's the power. Okay? So you do 3 to the second power first, which is 9, and then you say the opposite of 9, which is negative 9. Okay, so it's really important that you know the difference between, if the negative's in parentheses, it goes with it. If it's not, it doesn't. You just do the power first. Okay? So this is actually the opposite of 3 to the second, which is 9. So it's negative 9. Okay? So please star that in your notes, because that happens all the time. Okay. And yeah, let's just do a couple more examples. If I have x to the 5th power, what does that mean? It's basically just x times x times x times x times x, right? Does everybody understand that? That is completely different from this, right? What does that mean? 5 times x, right? So this is another thing students often confuse. These are completely different. This is x times x times x itself 5 times. This is just 5 times x, 5 times 1x. Okay. All right, so those are mistakes to look out for and be aware of. Let's go to our first rule, the product rule for exponents. So unfortunately, with these exponent things, we have a bunch of rules to look at. And let's go into the first rule, the product rule. Okay. The product rule is basically this. If I have some base, say a, raised to some power, or exponent m, and I'm multiplying that by another exponent, with the same base. Okay, so if I have multiple, I have an exponent with the base a times another exponent expression with the base a. Here's my rule for doing this. You take the base, leave it alone.
You add the exponent?
Yes, you do. You add the exponents. Okay? And this is our product rule for exponents. So, for example, and let's see why it's true. So let's do 3 to the second power times 3 to the fifth power. Okay? 3 to the second power times 3 to the fifth power. If I use my product rule for exponents, they both have the same base of 3. So I keep the 3, and then I add the exponents. 2 plus 5 is 7, right? So does everybody agree that that should be 3 to the 7th? Okay? Now, before we just take my word for it, or this product rule's word for it, let's see why, just to see why this rule works, okay? So, if I want to just, examine why this is true, what does 3 to the second power mean? That means 3 times 3, right? What does 3 to the fifth power mean? That means 3 times 3 times 3 times 3 times 3, right? Now, these are all being multiplied. So I have 3 times 3 times 3 times 3 times 3 times 3 times 3. If you just look at that, how many 3's do I have that I'm multiplying? 7. So this is why I just add them up. Okay, does everybody see that? So it's basically just 3 to the 7th. That's why this rule is the way it is. Okay. All right. Let's take a look at, say, 10 to the third times 10 to the fifth times 10 to the second. Okay. Again, all of them are the same base. So as long as you know this rule and are familiar, you should be able to handle it. So what is the answer to this? 10 to the 10. Yeah, and that's it. All right, let's start adding numbers in front. So let's say I have negative 3x to the second times 2x to the third. Okay? So now I'm kind of combining things. I have what's called a coefficient, which is the number in front of the variable, and I also have the variable raised to a power, or an exponent. Okay? So here's how you handle a problem like this. You multiply coefficients together, do that first, and then you handle the product rule for the exponents. Okay? So, negative 3 times 2 is negative 6. I take care of that first. Multiply the coefficients together first. And then x to the second times x to the third. We just learned that rule. It's x to the fifth. And that's how you guys handle multiplying with coefficients in front. All right? Let's try another one of those. Negative 10x to the third times 3x to the second times 5y. Okay, we look at this. Notice we have an x and x and we have a y. So that's a little bit different. But again, the same rule, negative 10 times 3 times 5. Go ahead and multiply all the coefficients together. And what does that give us?
Negative 150.
Negative 150, thank you. Now, with the x squared and the x cubed, that's going to become what?
6 or 5.
5, right. Add the exponents.
5 plus 5.
And then the y, it's just kind of by itself, right? He doesn't have another y friend to add to, so you just leave him. Times y. Okay, and that's it. So we can only add exponents when you're multiplying with the same base. All right? If this y is not the same base, then you obviously can't add that in. Okay? All right, let's do a multiple one. How about this? We have negative a squared bc times 2a to the third b squared c to the 10th. Okay? Now this problem looks a lot harder than it actually is, as long as you follow our rules. So, start with the coefficients. If I multiply the coefficients together, what is the coefficient of this guy? negative, right? Because there's a negative, so negative 1 times positive 2, which is negative 2, great. And then I have a squared times a cubed, which is a to the, add the exponents, fifth. B to the, now if there's no number up here, what is understood to be there? A 1, right. So b times b squared is b to the third, and c to the 11th. Okay? So it's just the same rule applied over and over, adding the exponents. Okay, let's take a look at our next rule. The next rule is the zero exponent. A raised to the 0 power is equal to 1. Okay. A raised to the 0 power is equal to 1. So, this rule, anytime you have an expression, and it doesn't matter how complicated in advance it is, if all of this is raised to the 0 power, anything raised to the 0 power, all of that just turns into 1. Okay? Now again, as I mentioned before, you guys have to be super careful when they start throwing negatives in there. Okay? So, let's take a look at some common mistakes. Again, this versus this. Okay? Vocalize the first one to me. What does that say? This one in parentheses is negative 10 raised to the 0 power, or negative 10 to the 0. Okay? But anything to the 0, we just said, is 1. Okay? This one, how I would say this is the opposite of 10 to the 0 power. The opposite of 10 to the 0. Well, 10 to the 0 is 1. The opposite of 1 is negative 1. Okay? So the reason why that comes out to be negative 1 is not because something raised to the 0 power is not 1, because it is. But the way that you read this is you do the power first, and then you apply the opposite sign. Okay? So please make sure, again, it's always a little tricky with the negatives. Yeah, you have a question?
So that applies to any number? Like if it was 22, it'd be 1? Or 22...
To the 0? Yeah, be 1. A million to the 0 would be 1. So anything to the 0, yes. Okay? All right, then after the 0 exponent, which is pretty easy, we have the power to a power rule, right? So power raised to a power. So what happens if you have an exponent expression already, and that expression is raised to another exponent? That gives us what's called power raised to a power. So notation, a raised to the n power already, but then that whole thing is raised to another power. Okay? Something like this. Well, before our rule was to keep the base and add the exponents. Here our rule is keep the base and multiply the exponents. Okay, so it's really important that you guys know when to do what. Only when you have a power raised to a power, that is the only time you ever multiply exponents. Okay? So when you have a power raised to a power. Okay, let's take a look at our first example, and let's see why this is the case. Let's start with 3 to the 2nd power raised to the 3rd power. By this rule, what is our answer supposed to be?
5, 3 to the 5th power.
So again, this is the only case in which we multiply the exponents, right? So what is 2 times 3? 3 to the 6, right. So, only when you have power to a power do you multiply them. Now let's see why this is the case, okay? What does something to the 3rd power mean? What does that mean? What do I do? Yeah, I just multiply this by itself 3 times. Is everybody with me on that? So this means take whatever's there and multiply by itself 3 times. Does everybody agree with what I'm about to do? So I'm just going to unhide my hand, And whatever's sitting there, I'm going to multiply it by itself 3 times. That's what our exponent means, right? But it happens to be 3 to the second. Great. But what rule did we just learn 10 minutes ago? If you have something like this and they're all the same base, what do you do with the exponents? You add them, right? 3 to the second times 3 to the second times 3 to the second. 2 plus 2 plus 2 is 6. That's why this rule works. It's basically you're adding this thing this many times, and adding something a certain amount of times is just multiplication. That make sense? Yeah. So that's why we multiply here. But a lot of students get confused as to when to multiply and when to add, so I'm trying to get rid of that confusion. The only time you ever multiply is when you have a power raised to a power. That's the only time. Okay? All right, let's do some of these problems. 3a squared, all raised to the 4th. Okay, when you have something like this, I have a coefficient of 3, and I have an exponential expression, a squared. Okay, so I'm really looking at 2 things. Okay, my coefficient and my exponential part. Both of them are being raised to the 4th power. Okay, so the way I handle this is I take my coefficient separately. 3 to the 4th power is just 3 to the 4th power. And then a squared raised to the 4th power, again, that's power raised to a power, so that's where I multiply the exponents, a to the 8th. So my answer for this problem is 3 to the 4th, a to the 8th. Okay? All right, let's take a look at some of the more difficult ones. Now let's start throwing things together. Okay, let's try this one. Z to the 3rd raised to the 2nd power times 5z to the 5th. Z to the 3rd raised to the 2nd power times 5z to the 5th. Okay? All right, when I look at this problem, the first thing that I notice is I have overall multiplication. We have something being multiplied by something. But I also have this power to a power. So let's go ahead and handle that first, right? What is z to the 3rd raised to the 2nd power? What rule do I use there? Z to the 6, right? Is everybody with me on that? So that's just z to the 6. Good. Handle that first. Times 5z to the 2nd. So now I'm using, I just used, oh, yeah, thank you. I just used my first rule, which is power to a power, but now I'm going to go to another rule. I have z to something times z to something, and what's my rule with that? What do I do with the z's? I add them, okay? And then you multiply the coefficients. So there's nothing in front of here understood to be 1. 1 times 5 is 5, and then z to the 11th power, because at that point I add them, okay? So again, don't get confused as to when you multiply, only when there's a power raised to a power, versus when you add. Z to some power times z to some power, that's when I add them. Okay? All right, let's try this one. Negative 3r4t cubed, all to the second. Negative 3r4t cubed, all in parentheses, raised to the 2nd power. All right, you tell me, how many things do I have inside the parentheses here? I have a coefficient guy, I have an r to the power guy, and a t to the power guy, right? So 3 kind of things that I have to deal with. All of them are being raised to the 2nd power, okay? So let's just do them individually. I have, this negative is in parentheses, so I have negative 3 to the 2nd power, which means negative 3 times negative 3. That's what it means. And what is negative 3 times negative 3? Positive 9. Okay? So I handle the coefficients. I have r to the 4th power raised to the 2nd power. Power raised to a power. I multiply the exponents. R to the 8th. And the exact same thing. T to the 3rd raised to the 2nd. Power to a power. Multiply the exponents. T to the 6th. Okay? So you handle the coefficient piece and then each of the individual variable pieces. All right. Let's try this one. X to the 3rd y times x squared y to the 4th all raised to the 2nd. Why don't you guys give that one a shot? See what you get. All right, let's see how we did on this one. So I would probably want to handle and deal with this guy. X squared raised to the 2nd, y 4th raised to the 2nd. What does that come out to if I simplify? X to the 4th, y to the 8th. So now I have this, x cubed y times x4 y8, right? Now is the point where I keep the same base and I add the exponents. So you should get x to the 7, y to the 9. That's it, okay? So just be really clear when I'm multiplying the exponents versus when I'm adding them. Okay? Sometimes they'll throw some fractions at you, so let's take a look at one of those. 3x squared y divided by 5y to the 4th, all raised to the 3rd. Oh, I'm sorry, there's no y here. It's just 3x squared y. 3x squared over 5y to the 4th, all raised to the 3rd. Okay, so in terms of pieces, if I'm looking at individual pieces, I have this coefficient of 3, I have this x squared, I have this in the denominator a coefficient of 5, and a y to the 4th. So if I look at it, I kind of see 4 pieces that I have to deal with. All 4 of those pieces get raised to this 3rd power. Okay? So let's start with the 3. 3 to the 3rd power. Done. Now, if I go to this piece, x squared raised to the 3rd power. Power raised to a power. What do? Multiply, so 6. Down here, 5 to the 3rd. Make sure that each of those coefficients get raised to the power. That's another common mistake. And then y to the 12. Okay, and that's it. So basically, I just applied the rule to each piece, and then you're done. Okay. All right, the last part of this chapter, this section, is distributing and understanding that. So let's try this. 3a to the 3rd times 5a squared b plus 10a. Okay? So, what's happening here is now they're testing to see if you can distribute, which is something we've learned a long time ago, but when we distribute this times this, we actually have a rule on how to handle that now. Plus, and then when I distribute this times this, I have, similar bases, so I need to make sure I can handle the exponent part. Okay, let's try this first. So I have 3a to the 3rd times 5a squared b. All right? Let's just do that piece first. You multiply the coefficients together. 3 times 5 is 15. And then I start handling the exponents. A to the 3rd times a to the 2nd. A to the 3rd times a to the 2nd. I add the exponents and I get a to the 5th. And that b guy is just kind of hanging along for the ride. Then a plus sign. And then let's do this piece times this piece. What do you get for the coefficient part? 30. And what do I get for the exponent part?
A to the 4th.
A to the 4th. Exactly. Add the exponents. Okay? You guys should always be adding the exponents except for one case. When you have power raised to a power, that's when you multiply the exponents. Okay? So in stuff like this, you should be adding the exponents when you combine them. All right?
Do we keep going, or is that?
You would keep going if they were like terms, of course, but these are not like terms, right? Because they have different variables and different powers. Okay? All right, let's try one more of those. Ooh, okay, negative 2x squared y, parentheses, negative x cubed z minus 3xy plus 5z cubed. All right, do that one individually. You have this to deal with. You're distributing that negative 2x squared y to each piece. Some of them you can combine, multiply the variables so you add the exponents, and some you can't. All right, so the first piece, negative times a negative is positive. Positive 2, x squared times x to the third is x to the fifth, y z. Okay? The y and z didn't have anything to add, so you just leave it. Negative times negative again is positive. 2 times 3 is 6. X squared times x is x to the third. Y times y is y squared. Negative 2 times 5 is negative 10. What can I do with the variables in the last one? I have x squared y and I have z to the third. Is there anything that can be done? No. So just write them all next to each other. X squared y, z to the third. Okay.
Does it have to be in that order? Or?
It doesn't have to be, but generally when we're distributing, we just kind of follow the order that's given to us.
No, I'm not saying that, but like how you did, like how you did x.
Oh, yeah, no, you could do z cubed x squared y. Is that what you mean?
Alright.
Yeah. Commutative property still holds. A times b is the same as b times a. Any questions? Yes?
Like for the top example on the top of fraction, how when it went out it was like 3 times 3, and then on the other example you multiplied it out and it was like.
Great, yeah. So when do I multiply it out and when do I not?
Yeah.
So if I think it's a decent number that I can handle, I probably would. This one you could, like if you wrote 27 right there, it'd be correct. So I could have went to 27. So yeah, it's just whatever you feel
So it
like.
doesn't matter.
No, but if it was like 3 to the 30th, you'd probably just leave it, yeah. Yeah. So it doesn't matter. If it's a small number like that, you could write that as 27 or 3 to the 30th, yes. Okay? Other questions? All right, you guys have to get these rules down, so before we move on to the other stuff. Let me give you some problems.